So in today's video, we're going to take a look at the extreme value theorem, which is actually a very crucial theorem, a sort of prerequisite for a Rolle's theorem, which we're going to take a look at in the next video, and critical points and optimization and everything. And the extreme value theorem is actually extremely simple and very intuitive. And it's certainly a lot easier than something like the mean value theorem, which relates kind of tangent lines at particular points that are parallel to secant lines over intervals. The extreme value theorem is a lot more intuitive than that, and so we're just going to discuss it a little briefly. So what the extreme value theorem tells us is that if we have a function f which is continuous on the closed interval ab, then there exists two values, we'll call these values c and d, that are located or that are a member of this interval, so located within this interval ab, such that f of c is less than or equal to f of x, which is less than or equal to f of d for all x within ab, right? So we have f of c kind of as our lower point, f of d as our upper point. And this may look a little bit convoluted at first, but if I were to translate this into a little bit more intuitive terms, this essentially tells us that if f is continuous, then we will have a minimum value within this interval, and we will have a maximum value within this interval, where f of c would be our minimum and f of d would be our maximum. And so that's essentially all that it's telling us, is that if a function is continuous over an interval ab, then we're going to have a minimum in that interval and a maximum in that interval. And so let's go ahead and take a look at this kind of graphical representation of that. So let's say that this right over here is our value a, and let's say maybe, I don't know, let's pick this to be our value b right over here, right? And so essentially, what the extreme value theorem tells us, let me extend these boundaries a little bit so we can kind of see our interval a little bit clearer. And so what the extreme value theorem tells us is that if we're continuous over this interval, which, I mean, it seems that we are, right? So if we were to take from this point to this point, it seems as though our graph is continuous. If we're continuous over this interval, then our function f is going to have a maximum value and a minimum value located within this interval. And so let's actually, no, I'll keep this color. This is a pretty nice color. Okay. And so what we can do is we can just kind of look at this graphically and we can verify that this theorem holds, right? So if we take this point over here, it looks like at this point we have a local maximum, and we call this a local maximum because maybe it's not a maximum for the entire function, but just within this interval it looks like this point is our maximum. And then we also have a minimum, which could be like this point right over here. This looks to be a local minimum. And we're going to delve into these terms a little bit more later on. You don't really have to worry about them now. The point is that when we have a continuous function over a certain interval, then this theorem is just going to hold, right? And it makes sense. It's very intuitive. It just tells us that we're going to have a maximum within this interval and a minimum within this interval. And so if we were to pick kind of our values, like this value right over here, maybe this is 0. This could be our kind of d value, and then this one right over here could be our c value, right? Because it looks like we have a minimum at this particular point, or a minimum within this interval at this point c, and a maximum at this point d. And so really that's all that we need to know about the extreme value theorem. It's not very difficult, it's kind of intuitive. In the next video, we're going to take a look at a more particular case of the extreme value theorem that's a little bit more involved, and that's called Rolle's theorem, which essentially delves into sort of critical points and finding values for which the tangent line, or the slope of the tangent line, is equal to 0.